there, before we jump into writing code that makes decisions, we need to understand something really simple and really important called Boolean logic. It's all about just two things, true or false. That's it. Computers uses these two values to understand what's going on and decide what to do next. And that's where if statements come in. They let your code say if something is true, then do this. It's like teaching your program how to think. Let's get started. In programming, we often need to ask questions and make decisions. To do that, we use something called Boolean values. These are just two values, true and false. These are special keywords in Python and represent the result of a condition. For example, is 10 greater than 5? The response is a Boolean value, meaning the value is either true or false.
Print true. Print false. These are not strings. You don't put them in quotes. They are their own data type called bool in Python.
Now let's look at how we create Boolean values. We use comparison operators to compare values and get a result of true or false. These expressions ask questions and return true or false. For example, let's see how Python runs this code. The expression 2 equal to 2 is a comparison operation that evaluates to true. The print function then outputs the result, which is true, to the console. Same for the following examples. The expression 2 less than 5 checks whether 2 is less than 5. Since this is true, the print function outputs true. Let's take an example where the output is false. In the following example, is 4 greater than 7? No. So 4 greater than 7 evaluates to false, and the print function also prints false. The expression 34 less than or equal to 89 evaluates to true, and the output is true. Print 3 equal to 9. Is 3 equal to 9? No. So this expression evaluates to false, and the print function outputs false. Print 3 less than or equal to 1. Is 3 less than or equal to 1? No. So this expression evaluates to false, and the output of print in this example is false. Same for print 5 not equal to 5. Let's see how Python runs this code. Sometimes we want to combine more than one condition. For example, we might want to check if someone is over 18 and has a student ID. That's where logical operators come in. The AND operator checks whether both conditions are true. If both are true, the entire expression evaluates to true. In this example, 5 greater than 3 is true. 8 greater than 6 is also true. Since both conditions are true, the whole expression 5 greater than 3 and 8 greater than 6 evaluates to true, and print function will print true. The OR operator checks whether at least one of the conditions is true. If either condition is true, the entire expression evaluates to true. In this example, 5 less than 3 is false. 10 greater than 1 is true. Since one of the two conditions is true, the whole expression evaluates to true, and the print function will output true. After showing how to combine conditions using the Boolean operators AND and OR, I will now give an example of the NOT operator. The not operator in Python reverses a Boolean value. Not true becomes false, and not false becomes true. Let's break down the two lines. Print not true. True is a Boolean value. Applying not to true gives false, so this prints false. Print not 5 greater than 3. 5 greater than 3 evaluates to true. Not true becomes false, so this also prints false. This brings us to the end of this first part, where we explored the basics of Boolean logic. In the next part, we'll build on this foundation and dive into if statements, where you will see how Boolean logic helps programs make choices and respond to different situations. Thanks for watching, and I look forward to seeing you in part 2.